Hello everybody, I'm Dr. Josh Redstone and I am back in the same outfit as the previous video to talk about Truth Tests Part 2. Now, today it's going to be a quick one. I'm just going to quickly wrap up the important things that I think would best serve all of you as we near the end of the term. You know, a lot of this stuff is going to be helpful when it comes to putting together your essays, especially when it comes to the argument component of your essays. You know, given the situation with COVID-19 and what I've done with the final exam, I've kind of made it so that the last little bits of material from namely this lecture and from the next lecture, which I'll talk about in a little bit, are somewhat truncated. Of course, I don't like leaving material out, but there's not really a whole heck of a lot I can do about this in the present situation. In any case, why don't we get started with a quick recap? Alright, so in our last lecture we discussed propositions and propositional attitudes, so statements about the world that can be true or false, and attitudes that we can take towards those propositions, so attitudes like belief. I also went over the justified and true belief account of knowledge, and we talked a little bit about Gettier cases as well, which are cases when we seem to have justified true beliefs, which a lot of people don't think seem to count as knowledge. So for an example of a Gettier case, you can see my previous lecture. We talked a little bit about formal logic and informal fallacies, deductive syllogisms, modus ponens, modus tollens, those kinds of things. But we spent most of our time discussing informal fallacies, which I think will be most helpful for you when it comes to developing your papers and the arguments therein. So what we're going to cover today is mostly just the stuff in Chapter 6 to do with warrantability and with the three different kinds of truth tests that Helen Buss Mitchell discusses in our textbook. And I'll probably wrap it up with a little tiny bit of discussion on truth in science and in religion. I did want to talk a little bit about cognitive biases, but I think it's probably better that I just leave things as they are, as I've laid them out so far. So, let's get started. Okay, so I'm going to start off by talking about warrantability. Now, warrantability, what is that? Well, think of a warrant, like I don't know, an arrest warrant, right? An arrest warrant is something that a police officer has to get from a judge in order to go and arrest somebody, and in order to obtain the warrant, they have to give some kind of evidence against the suspect so that they can go and arrest them and charge them, right? And in epistemology, and in philosophy more generally, a warrant is the same kind of thing. It provides some kind of justification or evidence that something is true or that something is the case. So we want our beliefs to have warrant. Even if they're true beliefs, we want there to be some warrantability. We want there to be warrantability in the propositions that we utter about the way the world is. We want warrantability. And there's different kinds of warrantability in epistemology. So let's take a look at each of them in turn. So the first example discussed in your textbook is something called logical warrantability. So earlier, if you recall our very limited discussion of formal logic when we talked about syllogisms and modus ponens and modus tollens and those kinds of arguments, well, the principles of formal logic, so that kind of logic provides logical warrantability. Likewise with predicate logic, propositional logic, modal logic, any kind of formal system, really, although we'll get to that in a moment, provides this kind of warrantability. So, for example, in a deductive argument like a deductive syllogism that we looked at, so what's a good example? All cats are mammals, Whiskers is a cat, therefore Whiskers is a mammal, right? We have a logical warrant for believing the truth of the conclusion of that argument, because the conclusion follows from the premises, and the premises are true. So that's logical warrantability. And there are more examples that you can find in the previous lecture as well. A related idea is semantic warrantability. So semantics here refers to meaning. Semantics is in fact the branch of linguistics devoted toward the study of meaning and how linguistic symbols get their meaning. In any case, when we have semantic warrantability, though that's a matter of definition, how we've defined words and what we've defined certain words as meaning, basically. How we use words in our language game, I guess, if you want to draw from Wittgenstein or something, right? So a statement like parrots are birds. Well, my belief that parrots are birds, my attitude of belief with respect to that proposition, and the truth of the proposition and my belief is a matter of semantic warrantability. So it's a matter of definition that parrots are birds, right? That's how we've defined those words. So, therefore, if I say something like crackers is a parent, crackers is a parrot, then you have semantic warrantability for believing crackers is a bird. So that's semantic warrantability. Closely related to logical warrantability is systemic warrantability. So, closely related to logic, but not limited to it. I mean, systemic warrantability would also apply in other kinds of deductive systems, like those of mathematics. So any kind of formal system, you could have systemic warrantability there. So what's an example? Well, we're all familiar with the Pythagorean theorem. Remember, we studied Pythagoras a little tiny bit in the beginning of this course when we were talking about the ancient Greeks. And of course, we all remember the Pythagorean theorem from math class. Forget when I learned, I guess it was elementary school. Anyway, a squared plus b squared equals c squared, right? Pythagorean theorem, we're all familiar with that. That theorem is systemically warranted because of all of the other axioms in the system of Euclidean geometry. That is to say that if somebody came along, maybe a kind of Cartesian evil genius, right, came along and erased all knowledge of the Pythagorean theorem from everybody's mind on Earth and from all of the mathematical books and everything like that, if someone just eliminated all of our knowledge of the Pythagorean theorem, we could still derive it again using all of the other axioms that we find within the system of Euclidean geometry. So therefore, belief in the Pythagorean theorem has systemic warrantability. We can be sure that it's true because its truth is a matter, or the warrant or justification that we have for believing that it's true comes, in this case, from the system of axioms within which this particular theorem exists and from which it can be derived logically. So this can apply to logic and mathematics. And the rationalist philosophers that we talked about in knowledge sources 1 and 2 would have been very emphatic about the importance of things like systemic warrantability, because the rationalist philosophers, of course, thought that knowledge comes from the mind or from rational principles. On the other hand, there's empirical warrantability. So in empirical warrantability, the evidence or the warrant for our beliefs or for the truth of the propositions that we express or that we believe in, whatever, must correspond to some actual object or event, something in the world, right? Something out there in reality. So the truth of a statement like World War II was fought between the Allied powers and the Axis powers has empirical warrantability, right? There are historical documents, there are other lines of historical evidence, there are people who were there when it happened, there are historical records of historical figures, and so on and so forth. So a statement like that or the truth of a statement like that depends upon empirical warrantability. Likewise for many propositions in history or archaeology. So the truth of a statement like the Earth orbits the Sun also depends upon empirical warrantability. And the kinds of warrants we're talking about here might be astronomical observations, right? So it's not just history and archaeology and these kinds of things, but a lot of the truth claims of the natural sciences depend upon empirical warrantability, right? And the empiricist philosophers that we talked about in Knowledge Sources 1 and 2 would have placed a greater emphasis on this kind of warrantability than on systemic warrantability. There's also testimonial warrantability. So testimonial warrantability, what is that? Well, testimony is honestly reported first-person experience. And if we have honestly reported first-person experience, that can serve as a testimonial warrant. So if a student honestly reports their discomfort by telling me it's too hot in the lecture hall, well, I have a testimonial warrant for believing the truth of what they've said. If they tell me honestly that the dog ate their homework, I have testimonial warrant for believing the truth of that statement. This is obviously very important in our everyday lives, but it's also important in areas of education. I mean, I'm either standing in a lecture hall or uploading a video onto YouTube, telling you things, and I'm honestly trying to tell you the truth when I do this, so you're believing the things that I'm teaching you sort of rests on the grounds of testimonial warrant, really. And of course this is also important in the behavioral sciences and in the social sciences. So sciences where we're studying human beings, psychology, sociology, political science, those kinds of things. In doing that work we rely on testimonial warrantability. So just think back to the justified true belief account of knowledge, for example, right? To have knowledge, S must believe that P must be true, and S must be justified in believing that P. That is to say, they must have some kind of evidence for believing in P, or that P is true. So to say our beliefs are justified, our true beliefs are justified, is to say that we have some kind of warrant for believing the truth of those of a particular proposition. So justified true beliefs are really just warranted true beliefs. Now, not all true beliefs have a warrant. That's something I think I gestured toward in the previous lecture but didn't state explicitly. But not all false beliefs are unwarranted. And there's an interesting table that you can find. It's table 6.1 in our textbook on page 255 of the edition we're using. I've come up with some different sentences in the table in my slides, but it's a nice little illustration of how we can have warranted true beliefs, warranted false beliefs, unwarranted true beliefs, and unwarranted false beliefs. So a warranted true belief might be something like water will evaporate into steam when heated. I mean, you could have empirical warrant for this, testimonial warrant even. And if you believe this, well, your belief is true. And of course you have a warrant for it. So that's a warranted true belief, if you believe that water will evaporate into steam. A warranted false belief might be something like the Earth is at the center of the solar system. In other words, the Sun orbits the Earth, not the other way around. We know that the Earth revolves around the Sun, but for many, many centuries we thought it was the other way around because the Earth seemed still and the Sun seemed to traverse the sky overhead. So we had warrant for believing that the Sun orbited the Earth, even though that's not the case. So that would be a warranted false belief. An unwarranted true belief, a proposition like Jane is the best cook in her philosophy class. Let's say that I have a student named Jane and she's phenomenal, like a gourmet, makes amazing gastronomic creations. Perhaps Jane believes she's the best cook in her philosophy class, and she may very well be, but it's not like I've ever had a cooking competition in my class. So Jane doesn't really have perhaps the kind of warrant she needs to make her true belief warranted, even if Jane does believe, rightly so, that she is the best cook in the class. An unwarranted false belief might be expressed by a proposition like, there are dinosaurs living on the dark side of the moon. Well, obviously there are no dinosaurs living on the dark side of the moon, so that's a false belief. But not only is it false, there is also no warrant at all for believing the truth of that proposition. There's no evidence to suggest that there are dinosaurs living on the dark side of the moon. If one were to argue for the truth of this statement, they would be making an appeal to ignorance, basically, which is the sort of informal fallacy I talked about in our previous lecture. All right, so much for warrantability. Why don't we talk now about each of the particular kinds of truth tests that Helen Buss Mitchell covers in Chapter 6. So the first of the three kinds of truth tests that I want to talk about today is the correspondence test. So any correspondence test is simply a test of whether a proposition, that is a statement about the world, accords with the way the world actually is, or with what is the case. So it tests whether the proposition is true by examining whether the proposition actually says something that is the case out in the world, right? So does the proposition in question correspond to a fact? You know, the proposition, the dog ate my homework, does that correspond to a fact? Did the dog really eat your homework? If it does, the proposition is true. If it doesn't, it's false. So it's very simple. And this kind of test is what we rely on for empirical warrantability, for example. So in the sciences, for example, scientists express things about the way the world is in whole sentences all the time, right? And not just that way, but other ways as well. Like they could do it systemically, like in physics, for example. But nonetheless, when it comes to testing hypotheses and forming theories, empirical warrantability is very important. And the truth of a lot of the propositions that we could express scientific claims with turns on whether those propositions actually correspond with the way the world is. Of course, there's a couple different viewpoints you can take toward how far this test will actually get you when it comes to knowledge making. Of course, if you're a realist or a representationalist, you believe that there is a mind-independent external world. So there are actually different states of affairs that exist out there in the world. You know, the world is a certain way. And true propositions or true beliefs will accurately represent those states of affairs out there in the world. So this is the kind of thing the correspondence test depends on. But if you're an anti-representationalist, that is, if you don't think that we can rationally speak about a world outside of our own limited way of perceiving the world, in other words, if you think we cannot get out of our egocentric predicament, you know, say you're a Kantian, right? We can't know the noumena, only the phenomena. Well, there's going to be a limited utility in the correspondence test. And the textbook talks a little bit about other thinkers who talked about what we can and cannot rationally speak about. None of that will be on the exam, but it's worth a look. You can look at the work of Quine or Wittgenstein, or even the postmodernists, I guess, if you want to. But that is all in your textbook. So let's move on to the next kind of test. So the next kind of test is called the coherence test, and it measures the coherency among statements within a system. So a coherence test is any kind of test that tests consistency among statements within a system. So this applies to formal systems like logic, but also mathematics. And it also applies to scientific theories. After all, in science, theories are very important. You know, oftentimes we hear theory tossed around in a kind of informal, colloquial kind of way, you know. For example, I have a theory about, I don't know, I have a theory about Palpatine from the latest Star Wars movie, or I have a theory about Darth Jar Jar, or, you know, this kind of thing, right? That doesn't really capture what a theory is, you know. Another kind of colloquial, everyday sort of thing you hear is that, you know, facts are what matter, facts are what are reliable, and theories are more hypothetical, theories are conjecture. In science, that is not what a theory refers to. In science, a theory is about as good as you can get. A theory, in science, is a big explanatory framework. It explains a set of observations or a set of facts using laws that we can derive from our observations. So a theory is higher than a fact in that kind of hierarchy of scientific understanding. Now, when we observe something new or something unknown about the natural world, a good explanation of that thing that we observe needs to fit, needs to cohere with that scientific theory. But of course, sometimes we observe things that suggest that our theory is not coherent and that it needs changing, and that's when we start having, you know, like paradigm shifts and scientific revolutions and those kinds of things, which I'm going to talk about in a moment. But in any case, that's the coherence test, is testing whether statements within a system cohere with one another. And finally, there's the pragmatic test. The pragmatic test really is just a test of whether something works. So is something true? Well, if it's true, it'll work. It'll be useful. That's pragmatism. And of course, the textbook talks about thinkers like William James and those people. Again, go ahead and take a look at that if you wish. I'm not going to get into it in too much detail. I just want you to know the sort of essentials behind the pragmatic test. So any test which asks whether something is true by virtue of the fact that it works or that it's successful at explaining or predicting or accomplishing something, that's a pragmatic test. Scientific pragmatism is something we encountered when we talked about quantum theory and relativity, especially quantum theory. You know, in quantum theory, we've got things like virtual particles and spooky action at a distance. And we can ask, you know, is this the way the world is really like? Or is it just that this is what the system that explains the world is like and it works? And can it tell us anything beyond that? Using ideas like virtual particles and all of that weird stuff we encounter in quantum physics, and using it because it works, and not because it tells us anything about the things in themselves, to use Kant's terminology, is being scientifically pragmatic. So that's the pragmatic test. So I'm just going to say a few brief words about truth claims in religion. This is not to single religion out, and indeed in our text, truth claims in history and law are also discussed. But you know, science and religion is one of those things, right? It's one of those classic dichotomies. Both make claims to truth, and truth claims in religion often rely on very different kinds of justification than truth claims in science. Which is not to say that you know, religion is inherently unreasonable. I don't think that it is. This is just to make you aware of some of the differences, some of the different standards in science and philosophy, and why they're different from the standards that truth claims in religion must adhere to. Oftentimes, you know, religious authority provides the ultimate kind of warranty for religious believers, and that could be authority from a figure or from a text, right? We could be talking about religious authority, there's a warrant for religious claim X because some religious figure said it, or because it is recorded in a text that is considered accurate and reliable by the followers of a particular religion, and so on and so forth, right? So religious authority is often all you need in religion to establish a truth claim. But as we saw before, appeal to authority is in fact an informal fallacy. Religious authority is not the only warranty that we find for truth claims in religion. There's also mystical experience. So mystical experience is like direct experience with the divine, or if not divine, if we're not talking about a theistic religion, direct experience with the ultimate reality or the true nature of reality. So this could include enlightenment in Buddhism, for example, if we're talking non-theistic examples, or understanding, Brahman in Hinduism. Mystical experiences like that can provide a pretty strong warrant for religiously inclined thinkers. Likewise for revelation, obviously this is important. Many, especially Western religions, so Judaism, Christianity, Islam, rely heavily on purported revelations. And this is not to pick on religion, okay? I'm not trying to pick on any particular religion or religious thinker here, but for atheists and agnostics, or even for scientists and philosophers who are theistic or deistic or pantheistic, this is not enough. It's just not enough. And moreover, we run into informal fallacies quite a bit when discussing truth claims in religion. And again, this is not to pick on religion. I really am not trying to pick on religion. I've said this in class before, and in fact, my journey into philosophy began with talking about religious questions, atheism, philosophy on the internet. I've been there. I've had these discussions in a formal sense or in an informal context, and that's what got me interested in studying it in a more formal, rigorous context, like a university. And I'm honestly not trying to pick on religion here, but for my students who are religious, I want you to have good reasons for what you believe. I really do. I'm not trying to change your minds about anything. I really want you to have the best reasons that you can for believing what you believe. So, with that said, I hope you take all of this, as a good faith attempt to shore up those knowledge claims in whatever religion you happen to adhere to. Likewise for everyone else, atheists, agnostics. Atheists and agnostics and even theistic or deistic philosophers are, on the whole, no better or worse as reasoning human beings than religious people. We all make errors of reason all the time. We're not very good at applying the rules of, formal logic in our day-to-day lives. We're just not. I'll link you with an example of how we're bad at applying these rules, called the Ways and Selection task, in the video description. So you can all do it and see how bad we all are at applying formal logic for reasoning about everyday scenarios. But in any case, that's all I want to say about truth claims in religion. Now let's move on to truth claims in science. Alright, so lastly for today, I want to talk about Thomas Kuhn's work on science, truth claims in science, scientific revolutions. And of course, Thomas Kuhn wrote a book in the 1970s, I believe, a very famous book called The Structure of Scientific Revolutions, where he outlines ideas like normal science and paradigms, and I'll just try to explain what each of those terms mean now. So a paradigm for Kuhn is a model which produces a coherent tradition of scientific research. So within a paradigm, we can do normal science. So science that takes place within a certain paradigm or theoretical system, or a system of different theories that is coherent, that produces results, that succeeds at explaining the way the world is like, or what the world is like. So Newtonian physics, for example, was a scientific paradigm. And within Newtonian physics, we were able to do what Kuhn calls normal science, studying bodies in motion, stuff like that, right? And Newtonian physics works very well for our sort of level of being, right? Where things are not too big and not too small. Newtonian physics works very well. But Newtonian physics does not work for, you know, areas of reality where we're traveling very, very fast, like close to the speed of light. Newtonian physics breaks down and can't explain what happens in the world when you're traveling near the speed of light. It can't explain what happens when you're near a very massive body, like a black hole. It also can't explain what goes on very, very in the realm of very small, like the area of reality that quantum mechanics is focused on. So the realm of the subatomic, right? Newtonian physics doesn't work for those. So it was a paradigm that worked, but now we have a couple of new competing paradigms, right? Relativity and quantum theory. Evolutionary theory is a paradigm, right? Within that paradigm, we have a theory, the theory of evolution. Within that theory, there are laws, like the laws of natural selection. And these explain things like, you know, how species change over time, how traits are inherited, how certain traits evolve, how certain behaviors evolve, all within a scientific paradigm. Of course, nowadays, quantum physics and relativity theory are like two incompatible paradigms. We need to unify them somehow, perhaps with string theory or loop quantum gravity or one of those candidate explanations. And my own area, cognitive science, has been argued by some to be pre-paradigmatic. In other words, we're not able to do normal science in cognitive science or the cognitive sciences yet. Depends on who you ask, whether cognitive science is a unified discipline or whether it's many different separate disciplines just working on similar problems. We may not have a paradigm for cognitive science yet, so perhaps cognitive science is pre-paradigmatic. In any case, those are paradigms or examples of paradigms, and normal science takes place within these paradigms. And when normal science begins to break down, that is, of course, when we get a scientific revolution. So the example used in the textbook for this kind of scientific revolution is the European scientific revolution, which is an example of a paradigm shift. So the Copernican Revolution, which kicked off the broader scientific revolution that took place in Europe at the end of the Dark Ages, was a paradigm shift. So remember, Copernicus argued that it was the sun that was at the center of the solar system, and that the Earth and other planets revolved around the sun. There was a competing explanation at the time. In fact, this had been the dominant explanation that went all the way back to the Ptolemaic scientists. So these were Greek scientists working in Egypt at the Library of Alexandria thousands of years ago, or many, many centuries ago. Ptolemy's explanation of the motion of the planets, in particular the retrograde motion of the planets that one would observe in the night sky, his explanation was a geocentric model with the Earth at the center, and the sun and all of the planets orbiting the Earth, but also turning on these celestial wheels. And it was a very complicated, cumbersome, precarious explanation of the motion of the planets. There were limits of how accurate you could be about predicting the motions of the planets on the Ptolemaic model. And the math was incredibly complicated. The math needed to make it work was very, very complicated. And along comes Copernicus, who had read, some pre-Socratic philosophers who thought that maybe the sun was at the center of the solar system. And Copernicus was able to explain the motion of the planets using a heliocentric model rather than a geocentric model. And the interesting thing here is that Copernicus's model did not explain the motion of the planets any better than Ptolemy's model did. But his math was much simpler. So he could make predictions that were just as accurate, but it was much simpler to do, which suggested that perhaps Copernicus was right. And indeed it turned out that Copernicus was mostly right. Copernicus wasn't exactly right. Copernicus thought that the planets orbited the sun in perfect circles. Of course, Johannes Kepler and Galileo Galilei would later go on to show that planets did not orbit in perfect circles. Rather, they orbited in ellipses. And it is when this breakthrough was made that research really kicked off for the heliocentric model, which finally eclipsed the geocentric model from Ptolemy. Darwin's work resulted in another paradigm shift, right? And I'm not talking about moving away from creationism here. But Darwin removed a lot of the teleological reasoning from biology by explaining the diversity of life with natural selection. For example, Darwin was able to show how the beauty and complexity in the natural world could occur without teleological reasoning, like that of William Paley, whom we talked about in some of our previous in-person lectures. Now, of course, Darwin's work is accepted amongst biologists. No serious biologist is not a Darwinist. But arguably, this paradigm shift is still being felt in certain conservative religious circles in the United States, where there is still actually an effort to teach creationism in the 21st century, I might add. So, within science, that paradigm shift has happened, but we're already still feeling it, or some people are already still feeling the repercussions of Darwin's work. His work continues to reverberate around the world in certain circles, and maybe there's a paradigm shift kind of getting ready to happen in physics too. I mean, we haven't unified quantum theory and relativity right away. So maybe we're in the middle of a paradigm shift, or maybe a paradigm shift will happen when we figure out how to unify those two theoretical systems. One which explains things on a very large scale, and the other which explains things on a very small scale. All right, that's about all I have. The next lecture will be our final proper lecture. I will do another lecture after that, just talking about tips for the final exam. But the next lecture is going to be all about the mind. We haven't really talked exclusively or expressly about the mind so far. We've kind of encountered it here and there throughout the class. But I thought it would be cool to dedicate an entire lecture to the modern understanding of the mind, or at least how our modern understanding of the mind emerged. So that is what we will be doing next time. So until then, I hope you all continue to hang in there. Thank you again for bearing with me as I try and get all of this online for you. It has not been easy, but I hope you all find this helpful. And if you have any questions about the material that we've covered today, send me an email, let me know in the comments section, and I will see you next time.